Hello everyone, this is Yashwan and today we are talking about SVM, which is Support Vector Machine. So let's understand about it. Support Vector Machine comes under supervised learning, means we will give data as well as label in training period. Supervised learning has two mainly categories, which is classification and regression. SVM mostly comes under classification. In sometimes we can see it in regression also, but mostly it comes under classification. So what is SVM? Let's understand it with a graph. So here, let's look at the right graph. Here we can see two classes are divided with the help of one line. Okay, so the work of SVM is this. It divide two classes or multiple classes with a hyperplane with a line which is called hyperplane. So this is hyperplane. This line which is going is hyperplane. Um, and the minimum the object which is at the minimum distance is called vector. So this is a vector and this is a vector, and the distance from the vector is called d minus and d here d plus. Okay, so this is called d minus and d plus, and the sum of d minus and d plus is called margin. So the function of margin is that the bigger the margin, the bigger will be the accuracy of the SVM's prediction. Means SVM will perform better if the margin is bigger, and if the margin is smaller, it will perform a uh, less better. Okay. Uh, One question arises in SVM that why are we just taking hyperplane like this? Why not like this or like this? So our goal with making a hyperplane is to divide accurately with margin which is larger. That is why we are not dividing like this, because it will not divide the classes properly, as well as the margin will be too less. So this margin is very suitable for this. The angle depends upon the how classes are spreaded. Uh, in this case, we are only looking at linear SVM. There is also non-linear SVM, but we will talk about it in some other video. So the linear SVM equation is this: function of x is equal to w into x plus b. Here w is the weight, x is the input, plus bias. And the equation of hyperplane is w into x plus b is equal to 0. It's similar to both are similar to equation of line. And here also it is weight, this is input, and this is bias. So let's see how we integrate SVM in our Python code by writing a code. So we have arrived in Google Meet, in Google Colab, and we will start writing the code. First step will be to import libraries to integrate it, to integrate the data set, to integrate the models, to plot it later. So first importing the libraries. Let's load the data set. Data will be at X. So we are taking two columns and all the rows. Let's create SVM model. Select our kernel, linear, one. Let's train our model. Think let's plot the decision boundary, which is hyperplane. Feature name y label. Right label. Let's plot the data PID dot scatter x the color I don't know what is happening with why. Let's मैंने पहले भी तो वाई वही रखा। वाई में गलती थी लेकिन वाई मैंने वही रखा। And this is how it's looking. But okay, so our representation of SCM is completed. Thank you for watching this. And I have attached my blog link, so please check out that also if you want to understand SVM better.